Hello everyone. Today I am going to show you how to do differentiation of logarithmic function, and this is in your textbook on section 5.5. So let's talk about differentiation of, I'll do in particular a natural logarithmic function here. For convenience, natural logarithmic function. Okay, so that side, let's say y equals ln x is called a natural logarithmic function with x greater than 0 is the definition. So there are two rules for this differentiation of logarithmic function. Rule number 1, derivative of ln x is 1 over x, and the rule number 2 is a chain rule. Derivative of ln u is equal to u prime over a u, and that's the chain rule. Okay, all right. So with that said, I'm going to show you two examples now. So say example 1, let's say a function is given as this, e to the x times ln x. In one of my video, I showed you how to find the derivative of natural exponential function, which is e to the x. Now watch out here, because this problem has two functions in product, natural exponential and natural logarithmic. So anytime derivative will follow the product rule of derivatives. So let's say I'm going to start taking the derivative with the product rule setup. So going back with our previous understanding of product rule, we can say this is e to the x d over dx of ln x plus ln x d over dx of e to the x. This is our product rule setup. Now each of them have their own rule of derivatives. This remains e to the x. Derivative of ln x that I just told you today is 1 over x. So put that in place. Plus this is now stay as it is ln x, and derivative of e to the x from previous section is e to the x. So that takes care of this one. So it's pretty much done for the derivatives. All you have to do is just to write a final simplified answer. I recognize there is the e to the x and there is the e to the x here as a common factor. So let's say I'm going to take common factor out of e to the x. So that will give me inside the remaining factors, which is 1 over x plus ln of x. And you can further simplify, but I don't think it's necessary. This can be as one of your final answer for the derivative of this function. Okay, so this tells me the example 1. Now let's try one with the example 2 that uses chain rule. So, okay, I'm here putting it in an example 2 now. So let's say I have a function which is f of x equals ln, and this is also another natural logarithmic function, ln x squared plus 1. As you see, we have to make it a change with a substitution for a u as a chain rule. So this is still the function. So it's become ln of a u, where u is identified as x squared plus 1. So when you know what is your u, you can go ahead and do this derivative, which is a 2x and u prime, correct? So now I'm going to use this chain rule here to find the derivative of this function, which is f prime of x. So this is going to be d dx of ln of a u now, because I made a substitution of a u here. And so the answer for this one is, again, following this definition, is u prime over a u. So the answer will be u prime is 2x, and putting the u back in place, which is a x squared plus 1. And this should be the final answer for the derivative of this natural logarithmic function.